Hey, hi, Rajan this side. Welcome to my YouTube channel. So today we will discuss all the four problems asked in today's LeetCode Weekly Contest 461. So let's start with the first problem. The first problem says you are given an integer array nums of size n, and this array is called trionic if there exist two indices p and q such that p is greater than 0 less than q and q is greater than p and less than n minus 1, right? And the three subarrays which you got, the first subarray is from index 0 to p, that is strictly increasing. The second subarray from p to q, which is strictly decreasing, and the third subarray from q to n minus 1, which is strictly increasing. If that is the case, if you got a subarray that satisfy all these three conditions, you have to return true, otherwise you have to return false, right? So yeah, this is a pretty basic problem, just an implementation problem. So your n is up to 100, right? So we can quickly go through all possible pairs of p and q, and we can try to check if the given array after choosing p and q is trionic or not, right? So let's see how we can approach it. So in the given problem, n can be up to 100, right? So, and as per the condition p is greater than 0 less than q and q is greater than p and less than n minus 1, the only possibilities of p could be from index 0 to n minus 1, index 0 to n minus 1. These are the only possibilities of p. And now what are the possibilities of q is greater than p, right? So the possibilities of q is, for any p, the possible combinations of q are starting from p plus 1 up to n minus 2, because q is less than n minus 1, right? So q should be less than n minus 1. The max value of q possible is n minus 2. So since n is up to 100, what we will do, we will go through all possible values of p, all possible values of q, and once you get p and q, we will try to form a subarray from index 0 to p, one subarray from index p to q, and one subarray from index q to n minus 1. And we will check if this subarray is strictly increasing and this subarray is strictly decreasing and this subarray is strictly increasing again. So if for any p and q, if all these three conditions hold true, it means that there exists a trionic array in the given array, right? So we can simply return true. And if you didn't get, if for all possible combination of p and q, if you didn't get any arrays of that holds all these three conditions true, you can return false, right? So let's see how we can write code for it. This is the code of first problem. So this is your size. Now I'm going through all possible possibilities of p, that is from 1 to n minus 1. Now I'm going through again all possibilities of q, which is from p plus 1 to n minus 2. And for these two p and q, I'm trying to see if we satisfy all the three conditions as I mentioned in the explanation part, right? All these three conditions. First subarray should be increasing, then the second subarray from p to q should be decreasing, and then the last subarray from q to n minus 1 should be increasing, right? So this OK is a variable which actually true if all these three subarrays are in order increasing, then decreasing, then increasing, right? So I'm just quickly checking from p1 to p if the so if all the next number is greater than the previous number, right? So this is for 0 to p, and for this I'm checking if the next number is smaller than the previous number, to check if this is in decreasing order, and the last one to check if this, like the last subarray, is increasing order. So I'm just checking if the current number is like more than the previous number. If you get OK, then just return true, and if you didn't get any like any trionic subarray by choosing all possible combination of p and q, you have to return false, right? So yeah, let's see the second problem. In the second problem, you are given an integer array weights of size n. that represents a weight of n parcels arranged in a straight line, and a shipment is defined as a contiguous subarray of the parcel. Okay, and a segment is considered balanced if the weight of the last parcel is strictly less than the maximum weight among all the parcel in that segment. Okay, now we have to select all non-overlapping contiguous balanced segments such that each parcel in is present in at most one segment. Okay, and parcel may remain unshipped. Now we return maximum possible number of balanced shipment that can be found. Okay, so like for example in the first test case 25143, the maximum possible balanced shipment could be 2. How? 251 is one shipment, so in 251 the minimum, like the last parcel has a weight of 1 and the maximum in this shipment is 5, so 1 is strictly less than 5, which is true. So this is one shipment, and for 433 is less than maximum, which is 4 in this part, like in this shipment, so this is also true. So 1 and 1, which is 2. Okay, right? Here it is 0 because like if you consider 4 and 4, the max is 4, mean is 4, so we have to check if the last one is the strictly lesser than the maximum weight, so which is not possible here, so answer is 0, right? So if you notice in this problem, the only thing which matters for any index is the next greater, right? For 1, what is the next greater weight of the parcel in the left side, which is 5. Here the thing which only matters is the next the next parcel who has the larger weight than current in the left side. So actually it's a, this problem is a kind of a variant of the next greater element or next smaller element problem, right? That is solved using stack. So I would highly recommend to find, like, to solve at least next smaller or next greater element using stack, right? Because n can be up to 10 to the power 5, right? So we cannot write a code for having complexity order of n square. So but like but using a stack, the complexity is like the amortized complexity is order of n. So I'll be using a stack here, so you can so before looking at the explanation part, I will highly recommend to learn how to find the next smaller element or next greater element in the array using a stack. So yeah, now let's see how we can approach this problem. So in the second problem, you are given the array of size n, right? Array of size n. So let's see you are at index I and you want to create a shipment that has index I as one of the parcel, right? And one more thing, if you notice, we have to find out the maximum possible number of balanced shipments, right? So tell me one thing, will it be optimal if you try to add this parcel into a shipment that has the smaller length, right? The smaller size. For example, let's say your I is 1, right? I is 1, and like, so before that you have let's say the I is 4, for example, and before that you have 3, you have 8, you have 1, you have again let's say 1. See, the one possibility is to create a balanced shipment is to take all these 3 parcel in the same shipment. In this case, your last parcel has a weight of 4 and the maximum among these is 8, and 4 is less than 8, so it's a balanced shipment. But is it optimal? No, because these two are redundant. If you remove these two, still this subarray is balanced, right? If you take just 3 8 3 and 4, this is still balanced. See, the max is 8 and the last one is 4. Again, this is less than 4 is 8 is greater than 4. So the thing is, once you get a next larger next greater element than 4, you should not go beyond that, because that will anyway not help you to find the maximum number of balance shipment. As per this explanation, this 1 and 1 weren't redundant, because anyway with 8, 3 and 4 you were successfully able to get a balance shipment, so no need to consider these two. So the main point in this problem is that the only configuration should be the next greater element. Like for example 4, you had the next greater element 8, so this is the only, I mean this summary is sufficient to give you a balanced shipment, right? So that's exactly what I'm going to do here. So for each index I will try to find the index j, which is the next greater element. This is my next greater element, and this can be found using stack in amortized complexity of order of n, because if you go a brute force approach, it would be order of n square or n log n maybe, but n log n still be fine, but if you go with the brute force approach, you would end up having order of n square solution, so that is not optimized. So we will use a stack here. So once you get this index j, which is the next greater element in the left side, so your answer would be, so I'll store this answer in a dp array. So dp of I actually tells you the maximum balanced shipment, maximum balanced shipment, maximum balanced shipments from index 0 to I, right? So what will be your dp of I? Your dp of I would be, this is one balanced shipment 1 plus dp of, since you have considered this as one of the balance shipment, now you have to find out the dp of j minus 1, right? That's all. This is the recursive approach, basic recursive solution. So dp of I would be 1 plus dp of j minus 1, and if there is no greater element on a left side which is more than I, in that situation your dp of I will be dp of I minus 1, right? Because this, now the ith element cannot be a part of any of the balanced shipments, right? Because there is no greater element present on the left side. So in that case your dp of I would be dp of I minus 1, and if you get any greater element, your dp of I would be 1 plus dp of j minus 1. Yeah, so this is all about the solution part. Now let's see how we can write code for it. This is the code of second problem. So you are given weight array, and this is the size of the weight array. I created a left array which essentially tells you the next greater element than weight of I on the left side of the given array, right? So left of I is the next greater element on the left side. Now this, I mean I have implemented is using stack. This is a pretty famous algorithm to find the next greater and next smaller element using stack in order of n complexity, amortized complexity of order of n. So I would highly recommend to learn it first. So this is that implementation. Now once you do that, once you find the left array calculation, now we can jump over to the dp array. So this is your dp array. For dp of I tells you your dp of I is essentially, your dp of I is max number of balanced shipments from index 0 to I, right? So dp of I is the max number of balanced shipments from index 0 to I. So for dp of 0, just one partial, so it cannot be a part of any shipment. So dp of 0 is 0. Now we are going from index 1 to n. Now we first find the jth index, which is left of I, which essentially the next greater element than weight of I on the left side, right? So once you get a j, so if j is not equals to -1, means that there exists a number which is more than the current number on the left side. So if you get it, so dp of I is equal to 1 plus dp of j minus 1. Since like we just have to check if j is not 0. If j is not 0, then it should be dp of j minus 1, otherwise 0, right? So this is the case when you updated dp of I is equal to 1 plus dp of j minus 1. Otherwise, if j is equal to minus 1, means that there is no element on a left side which is more than the current number, right? So in that case, your dp of I would be dp of I minus 1, because now this number cannot be a part of any of the balanced shipments. So dp of I minus 1, and at the end return dp of n minus 1, right? So yeah, this is the code of second problem. Now let's look at the third problem. In the third problem, you are given a string s of length n and an integer array order, where order is the permutation of the number from 0 to n minus 1, right? So it's a permutation of all the numbers from 0 to n minus 1. Now starting at time t equals to 0, what we have to do, we have to replace the character at index order of t in the given string s with star, all right? And a substring is valid if it contains at least one star. Okay, now a string is active if the total number of valid substring is at least k. Okay, so the total number of valid substring is at least k, and a valid substring contains at least one star. Okay, and we have to return the minimum time at which the string s become active, and if it is impossible, return -1. Okay. I think this is a this is a binary search problem. So we know that if for any time t, if your given string become active, for all the time more than t, it will always be active, right? For t, if it is active, so for time t plus 1, t plus 2, t plus 3, it will always be active, because the number of valid substring is anyway going to increase once you increase the time, right? So it's a binary search problem. Let's see how we can find a solution for it. So in the third problem, we are given the order array, right? Order array, and which is the permutation of numbers from 0 to n minus 1, right? And if you observe it closely, if you add more stars in the given string, it will always increase the chances of having the count of valid substring more, right? It will always increase the count of valid substrings, because let's say if you have a certain number of stars in the given string, and for this your number of valid substrings are, let's say, z. Can I say if you add more stars to it along with these three, if you add more stars, your number of valid substring will always be greater than or equals to g, right? Because a valid substring contains stars. So if you add more stars, you are increasing the chances of having more valid substrings, right? So can I do one thing? This is the order. Let's say for at this index k, if having stars as at these many position from 0, 1 to k minus 1, if your string become active, right? If your string become active, so as per the definition, your string is active if the total number of valid substring is greater than or equals to k, right? This case different than this, so this is the index value. Let me take it idx index, that would be easy. Index, right? So for the at this index, let's say for index 0 to idx, if you change order of I with the star in the given string as, if your string become active, right? Active means, for this, let's say your count of valid substring is z. So if it is active, means this should be greater than or equals to k. We know that if you add more stars to it, your z will always be more, right? It will never be lesser. So that would again satisfy this condition, greater than or equals to k, z star. Again, this z star will greater than or equal to k, means that all this will be active again, right? So we just have to find out the lower index, the minimum index in this order such that this become active. This is what the problem statement. Now to implement that, what we can do, a binary search. From index 0 to n minus 1 in this order array. Let's say you choose this index idx. So you check if considering orders index from 0 to idx, if the arrays become active or not. If it is active, so you can consider this as one of the potential answer, and don't go beyond that. Don't go in the right half, because we know that in the right half if you go, it will still be active. So go in the left half. Go in the left half. Left half. And the second condition, if it is not active, right? So considering orders from index 0 to idx, if it is not active, means that if you consider lesser number of stars, it will still be not active, because if for 0 to index, if it is not active, if you reduce stars, it will even, I mean, the number of valid substring would be less than z, right? So it will never be active if you go on the left half. So in this case, go to the right half. So that's exactly what we do in the binary search problems. Find a low and high, go to mid, check for mid. If for mid you get an answer, update your low and high accordingly. So here, if you get the answer, go to the left half. If you didn't get the answer, go to the right half. Right? I wanted to quickly discuss how to find all the number of valid substring. Right? So let's say this is your given string. Right? You have a couple of stars into it. You have couple of stars, right? You have a couple of stars. So the total number of valid substrings. So one thing, the valid substring contains stars. Like any of the valid substring will contain at least one star. So total number of valid substring would be, let's say the size of the given array is n, would be n plus 1 divided by 2 minus all these contiguous subarrays which doesn't have any stars. Right? Let's say the length is here is 2 1 2 1, right? Minus how many number of subarrays possible of for this subarray of size 2, which is let's say the length is len minus summation of I from 0 to k. I mean 0 to k means all these k contiguous subarrays which doesn't have any star. Len of I into len of I plus 1 divided by 2. So in this case it's 1 into 2 divided by 2, which is 1, plus for this 2 into 2 plus 3, sorry 2 plus 1 divided by 2, which is 3 plus 1 plus 3. So, and let's say a1 2 3 4 5 6 7 8 9 10. So the total number of valid substring for this case would be 10 into 10 plus 1 divided by 2 minus 3 plus 3 6 7 8. So these many number of valid substring possible, right? So yeah, let's have a write code for it. This is the code of third problem. So you are given a string, the order vector and the integer key. So I calculated the size of the given string, and this is a binary search implementation. So I took low and high, and my answer initially is -1. So low is 0, high is n minus 1, because we have to find out the minimum index at which you get the string active, right? So low is equal to y. I calculated mid. Now what I'll be doing, I'll be considering all the indexes in the given order vector from index 0 to mid. So I created a local copy of the original string. Now for all the orders indexes from index 0 to t, I just updated that index to star. I just replaced that character with a star. Now once you do that, I'll try to find all the not valid substrings, right? And so, and this current is essentially the number of contiguous non-star character, right, non-star character. And so I'm going through from index 0 to n. Now if my current index is star, I just updated my not valid would be current into current plus 1 divided by 2, and I reset current to 0. And if it's a non-star, I just incremented my current, right? And at the end, once your loop finishes, just update your not valid once again, because there might be possibilities that you get couple of non-star character at the end. So for that you don't like, you won't be able to update in this loop, right? So I updated it here to handle these cases. So once you calculate not valid, your valid would be n into n plus 1 divided by 2 minus non-valid, right? Not. So once you find the valid, just check if your value is greater than or equals to k. If that is true, it means that for the indexes in the given order vector from index 0 to mid, you can successfully able to make the string active, right? Yeah, after replacing the character with a star, means that like you don't have to go to the right half. If you increase mid value, you still it will be active. So go in the left half. To do that, you updated your high value and you updated your answer. If that is not true, if it is not active, means that if you go, like if you reduce the mid value, it will still be non-active, because if you remove the stars, you are going to reduce the count of valid substrings, right? So you have to go in the right half, increase your index. So just your low would be mid plus 1, and at the end return your answer. So this is the code of thought problem. If you find the video helpful, please subscribe and share my channel. Yeah, thanks for watching. Have a nice day.